Okay, here is a slightly more complicated example, so we'll just kind of rip through this. Hopefully you followed the other one, so we'll kind of skip to this business of finding x-intercepts, which should obviously be 2, which has multiplicity 3, negative 3, which has multiplicity 2, 5, and negative 1. Again, the multiplicity 3 means that it's going to do something like that through the root, and multiplicity 2 means it's going to do something like that through the root, or through the 0, or the x-intercept. Y-intercept, it takes a little bit of calculation here. Negative 2 cubed is, we'll just write this down, negative 2 cubed times 3 squared. I'm plugging in x is 0. Pause the video if you don't see that. If you pause the video and still don't see why this is true, come ask. So I'm putting in x as 0, so this is negative 2 cubed, 3 squared, negative 5, 1, plus out front, should put it over here, there's a negative 1/5. So I multiply all that stuff together very carefully. This negative 1/5 cancels with this negative 5. That was convenient. Negative 2 cubed is negative 8. 3 squared is 9. So we get a y-intercept of negative 72. Yikers. Remember, we're just making rough sketches, so we're just going to label our graph with a negative 72. So we've got the x-intercepts, we've got the y-intercepts, we've got the degree, or which dictates the end behavior. The degree is 1, 2, 3, 4, 5, 6, 7, which means, of course, it's got odd end behavior, so it's going to be bloop and bloop, except, aghast. There's a negative sign there, so it's really got, because it's negative, instead, it's going to be kabloop and kabloop, like that. So now we're going to try to put all that stuff together. So I'm going to scroll down here. I think I'm going to have to scroll a little. Can I keep the x-intercept? Yeah, I'll try to keep the x-intercepts on there. Try to keep all the information there. Make our graph. We got x-intercepts all the way up to 5. Down to negative 3, so we got 1, 2, 3, 4, 5, an x-intercept. X-intercept at negative 1. X-intercept at negative 1, 2, 3. That's got odd multiplicity. And an x-intercept at 2 with even multiplicity. We know it has to come in from here. And it has to go out here. Because it's odd 7th degree. I'm just going to scroll up a tiny bit. I'm losing my x-intercepts, but I wrote them down there. And we're going to put on a y-intercept of negative 72, so we're just going to put this down here and call it negative 72. What? We can do that? Yes. Okay, we're going to bounce at negative 3, so we're going to come in down here and it's going to go blook. It's bouncing off there because it's multiplicity 2. It's going to come back over here and pick up this root at negative 1, which has no multiplicity, so it's going blink. It's going way down to get this negative 72, and then it's got to come back up to our root of positive 2, which has multiplicity 3. So now we're going to be coming up here and going, pretty subtle. It's like it's going to bounce, but it doesn't, because that's our odd multiplicity. Pause the video and take a look at that. Now it's going to go up here, probably quite a distance. These are pretty steep, so when you graph them on your calculator, shoom, and then that through that root right there. When you graph them on your calculator, this is negative 72. You're going to have to get your y window. When you verify this on your calculator, you need a big y window, probably something on the order of negative 100 to 100, but a small x window. because our x values only want to go out to 5 or 6, and negative 5 or 6. So we need to, on our calculator, if we want to get a reasonable picture of this behavior, look at a skewed window. Negative 5 to 5 would probably work on a calculator. Yes, thank you. We'll be here all week.